Warm regards, everybody. Today's topic is Coastal Island Environmental Management Decision Support through Geo-Hydrologic Modeling Approach. And Devin Winslet, my student, created this project, and I will be presenting on his behalf. He already graduated from our Institute of Environmental Spatial Analysis of UNG. A little bit background on the study. This study is conducted on Sapelo Island. It's a barrier island that is found along the Georgia's eastern Atlantic shore. Barrier islands are a crucial part of the coastline geomorphology. This is not limited to the fact they provide a habitat to creatures that live within the marsh and coastal environment. They also provide protection to Georgia's coastline from big threats such as winds, waves, and even giant storms such as hurricanes. One of the major detriment that these barrier islands are facing is erosion. Not only do they see a vast quantity of erosion on their shorelines, but the islands are also always being eroded from within. The study objectives are such that we intend to delineate the micro-watersheds on Sapelo Island and determine spatial erosion vulnerability on the island along with the shoreline erosion. The study also determined the impact of erosion on the hydrologically designed detailed river network on the island. For this purpose, we used three different models. I will discuss that a little later. So let's talk about the area of interest. We already talked about Sapelo Island. This is the area of interest. Sapelo Island is in McIntosh County, Georgia. You can see in Georgia the red dot and the blown up Sapelo Island entire map in the right. Your Sapelo Island, as explained earlier, it's a barrier island located in McIntosh County, Georgia. It is illegal to visit the island without the proper permit. State tourism authorities provide the permit. And by the way, approximately 97% of the island is owned by Georgia State or the Department of Natural Resources of Georgia, and remainder 3% is under private ownership. The western perimeter of Sapelo is Sapelo Island National Estuarine Research Reserve, which is part of the NOAA's National Estuarine Research Reserve system. As I told earlier, we used actually three different models, and those models are kind of concurrently used, and when they combine together, it provides the environmental management decision support system for the upkeeping of the island or the barrier island. So those three models, those are advanced geospatial models: ArcHydro, RUSLE, and QSWAT. ArcHydro is an add-in to the ArcGIS Pro software. So this ArcHydro model was used to design the watersheds or micro-watersheds and the stream network of the island. Because NSD data does not provide a good stream network or watershed information. So that is the reason ArcHydro was used. RUSLE is the your universal solveness equation, revised one. So we actually developed our own automated RUSLE model in ArcGIS Pro. So that your RUSLE model actually provided the erosion risk, spatial locational risk in the island. And QSWAT is a tricky model because the SWAT model runs on QGIS. But it was not that difficult because the model was in US and most of the SWAT related data required to run the model is available as default. So we used the DEM, landuse, and the SURGO data downloaded from authentic sources and provided to SWAT model in QGIS. So QSWAT actually provided us to find out the sediment load in the streams, like in which a stream is having higher sediment load along with the stream flow. So ArcHydro model, important features, it needs a DEM. In our case, we use the LiDAR based DEM, which was 1 meter resolution. So that way, in a flat area in the island, which is a little bit flatter side, so it would be easy. It was easy for us to delineate intense stream network and the micro watersheds. And ArcHydro model provides flow direction raster, flow accumulation raster, 8 direction 4-point method based 4-point locations, and stream network design, and at the end it provides watershed design. And for the model, you have the we provided here the PDF file, so that would explain about the model. Anybody interested, so they can go to the PDF file and learn about it. And these are some of the data, like DEM, which is created from the 1 meter DEM, which is created from the LiDAR data available through the NOAA, your LiDAR data inventory. So you have that here. We obtained it actually from Georgia Tech site. And then this is the DEM modified to fill the sinks. And without the sink filling, the DEM will not provide proper result. And how the sink fill works, the web link is provided here by David. Then the slope, this is created from the DEM, and the link is provided to understand how slope is essential for environmental management and how it works. And the flow direction raster initially got created after we do the watershed delineation. So based on the flow direction, all blue, it is actually not all blue. In to be stream location, you will have a higher accumulation of water. And now this one is showing the 4 points. These 4 points actually will delineate the micro watersheds for us. 41 micro watershed we have. It is actually providing later stage advantage for us to find out which subwatershed is vulnerable for erosion, or the streams passing through the subwatershed is vulnerable for erosion. To find out the erosion model, we created our own RUSLE model, which is actually automated, and it is created on ArcGIS Pro ModelBuilder platform. And we need the equation, the RKLSCP. R stands for rainfall residuity, K for soil erodibility, S for slope length is L, and slope gradient is S, C is the land cover or the crop management factor, and P is the conservation practice factor. And this PDF explains well about the basic RUSLE model. And we use different data, that RKLSCP to be created, rasterized data to be created for each factor. And your K, L, and S factors were obtained from the gridded SURGO data, which is downloaded from the USDA NRCS data gateway, geospatial data gateway. And national land cover data was used to create the C and P factor. And USLE iso-eroded map was used to find R factor for the area of interest at the Sapelo. Then how we set it up, this is a very detailed process, because gSSURGO is a complicated way. gSSURGO data is connected to the your tabular data, like the attribute tables. So this one, the join field tool, actually help us to join all the attributes, or the tabular data comes with the geodatabase. So map unit raster is the base raster, which is 10-meter resolution, and mu key was used to join mu agat table, and next mu key was used to join your component table, and then co key comes from the mu key, component that is used to join your sea horizon. And with these three tables, most of the possible RUSLE related attributes are available, like the K, L, and S. So here is the model. The soil data created the K, L, and S raster. The NLCD data created the C raster by reclassifying it using the your crop management factor values. Then each were multiplied to each other. So your L and the R factor was found from the like your iso-oriented map. R factor for the small island was a single number. We will see that later. It is 400. So R factor was multiplied by the K factor or times to give RK raster. RK raster was multiplied with L raster to give RKL raster. And then actually the the K and L, so those are decimal values available in the SURGO database. So we multiplied to make it integers. Then after we got multiplied it, then we divided whatever multiplication we did to get the RKL divide raster. Then that one was multiplied with S raster to give us RKLS raster. And again the S factor was also kind of multiplied with 100 to give us the integer value, as it was available as a decimal value. Then C raster was multiplied with the RKLS raster to get at RKLSC. Then again multiplied with a factor, constant factor we use for conservation practice. So get the RKLSCP, and wherever we multiplied your tens or hundreds to make the values into integers, so we kind of divided at the end, and it gives us the A raster. These are the approach we followed. This is the ISO rainfall eligibility factor map or ISO map. You can see Sapelo Island is within the 400 range. And this one is the K factor map created from the gSSURGO, and values are different values are there. As I told earlier, the values are in decimal, so 100 was multiplied to it to make it an integer value, and later that 100 was divided from the final result. And then you can see L factor the same way. When it was multiplied, it was actually not multiplied because it comes with the numerical or the integer value, so 3046. And S also the same way, 1 and 7. And this one is C factor. We use this vegetation cover C value. Already ARS folks created that. So using that, NLCD data were converted to C value numbers, and it was multiplied by 100 actually, because check that some values are 2 decimals. So that 100 was divided at the end. You will see that. This one is the P factor. As we told, we use 0.5, like 50% like conservation practice. If it is well conserved, then it would be 1. That is 100% conserved. So in this case, because it is maintained by or managed by your Georgia Department of Natural Resources, so we provided 50% value. So this multiplied by 10 to give 5, then later on it was. So you can see that the division, multiplication, all these things, and these are numbers here. Then final A raster, you can see the values. Most of the yellow area is a low erosion area, that is 3 tons per hectare, and rest of them 5, 15, 31, 261 So more than 5 is considered as like higher erosion. So it always the best kind of allowed erosion rate is less than 5 tons per hectare. So it shows that the final result from RUSLE, most of the island is having higher erosion rate, and it is understood. Then the QSWAT model, it was not able to really work with it because most of the data is US data, and QSWAT or the SWAT model works really well with the SURGO, your national land cover, and DEM. So we provided this data to the QSWAT. Then this is the DEM. This one is the river and stream outlet got created out of it. Then these are the watersheds got created, and we did not go with 116 watersheds. That was too many. So with QSWAT, we went with like around 44 watersheds, and the analysis was conducted based on those 44 micro. Actually 45. Then this shows the sediment carried in the rivers and streams. So northern side of the island, northeastern side of the island has a higher sediment load, and this is more to the northern side of the coast. And this one shows actually our simulated value from 2015 to 2025. It's showing 2018 was a very high your erosion was happening in that watershed number 3, and it is expected that it will went down. It will go down in 2024, 2025, and generally 2018 was the heavy rainfall year. So that is the reason we have most of the peaks with sediment load in those unselected watersheds. Now finally, summary and conclusion. ArcHydro software was used to on ArcGIS Pro platform to delineate little micro watersheds and intense, which is not found on NHD dataset, stream network with the help of 1 meter resolution LiDAR based DEM. RUSLE model was also developed on ArcGIS Pro ModelBuilder platform to determine the spatial soil erosion mounting on the island, including shorelines. As we explained earlier, most of the island is having higher allowable rate erosion, which is 5 tons per hectare. Only few area was less than 5, within 3 tons per hectare range. And the QSWAT model explained that the northern side, northeastern side of the your island has the stream has a higher stream flow, at the same time more eroded soil or the sediment flow in those areas. So when these 3 models got combined, so the geo-hydrologic model approach actually providing environmental managers, they are in charge of the Sapelo to upkeep this island well, and that's a better decision support they can use to really manage the watershed for better environment. Okay, so this is all, and this study actually uses 3 different high-end models to actually provide decision support to sustainably manage the islands, manage the environment of the island, or manage the island itself. Thank you. Any questions?